I pledge my word that I shall defeat this worthless opponent.
Alright guys, Krulldog here, and today I'm going to prove to you that the RNG system in Duel Links is not random. So lately I've been seeing Gazuki quite a lot, so all I'm going to do is reduce it to 1, and I'm going to put an extra ultra rare card. I think this trap will do. Actually, no, I've got a better idea. I've actually got the Book of Money. So I'm gonna use that because that's definitely rigged. That's definitely gonna make Gazuki appear in hand more times than it should. Okay, so first duel, let's see if we get on our first duel. First duel. Now would you look at that? The first card we drew was a Gazuki. Think that's a fluke? No, let's try again. And again, 2 times in a row. Okay, there's no way we're gonna get the 3rd time in a row. It's just statistically impossible. Stuff like this never happens in life.
Duel.
3 times in a row. It's just impossible. It is impossible. This proves that the RNG system in Duel Links is rigged, right? But no, I've actually done this 100 times. Now I've seen Gazuki 22 times in 100 duels, which is kinda expected. So I hope this shows how important a sample size is when doing statistical calculations. But how do I know that my sample size of 100 duels is accurate enough? Well, unfortunately, in statistics there's more than one way to do stuff. And I couldn't find a magical formula that just tells me yes, no, or do this many. But a lot of people would agree that the minimal sample size you would need is usually 100 to get any meaningful data. So what I'm gonna do with this data is basically use the chi-square equation to see if I can reject the idea that the RNG system in Duel Links is fair. And the way we do it is basically by making a null hypothesis. In this case, it would be that the deck is fair, meaning the RNG system is also fair, and the alternative, the game is rigged. However, this does create a different problem. What if it's my deck that's fair, and if I use a different deck, well, that one would be rigged. So, to avoid this problem, I've actually collected data for a second deck, and I'm gonna do the exact same thing with it, and I'm basically gonna use both of them to see if I can reject my null hypothesis. Before we start any calculations, let's address one thing, and that's a computer's ability to actually make random numbers. So, computers are capable of true random numbers, but that involves measuring a random event outside of its system, so I really doubt that is something that Konami uses for Duel Links. So, Duel Links definitely uses something called pseudo-random numbers. So that proves it can be manipulated. In fact, speedrunners have actually learned to manipulate the RNG system in some of the games to make certain items drop. Well, luckily for us, computers have gotten a lot better in generating random numbers. And in fact, we have online casinos where there are certain organizations that will monitor the RNG system that they use and give out certificates to confirm the RNG system is fair. So if online casinos can do it, why not a game like Duel Links? Well, like I've mentioned, I've collected data for 2 decks and you can see them on the screen now. Don't worry about all of the numbers and what they mean for now. The only thing I will mention is this column here, that's how many times I've actually drawn the card in 100 duels. If you do want to verify all of the information yourself or use it for your own calculations, We'll probably post them as a private video and put the link in the description of this one. So just keep an eye out if you are interested in those videos. So before we begin, I'm just gonna mention some part of maths you probably expected to see here, but that I'm not actually gonna be using. So the first one is the choose function. You might have seen this before and you might even know what it does. Basically, it can tell you the total amount of combinations you can get. Fair enough, if some cards do repeat, they won't be unique, but they are still part of the combination. So if you have a deck of 20 cards and you draw 4 cards, that's a total of 4,845 possible starting hands. Just a bit of fun maths there for you. But what you probably wanted to know is how do those online Yu-Gi-Oh calculators work out the odds of you getting a certain card in your starting hand. So it's actually quite easy. What we do is work out the probability of not getting the card, subtract that from 1, and 1 in statistics represents 100%. So you subtract the odds of not getting the card from 1 and you get the odds of actually getting the card. And the way we work out the odds of not getting the card is, for example, if you have 1 copy of the card in your deck. So on the first draw, the odds are 19 divided by 20, because you have 19 cards that you don't want to draw out of your 20. On the second draw, your deck has decreased by 1 card, so it would be 18 out of 19, and so on and so on and so on, and you can do this for any deck size and any amount of copies of the card you actually want to draw, including searchers for it. So on the screen you can see an example. If you have 1 copy of a card in your deck, you have a 20% chance of actually starting with that card in your hand. But now let's go back to our chi-square equation and see if there is something wrong with Duel Links. So on the screen right now you should see 2 tables, and we have the observed value, so basically how many times I've drawn the card, and then we have the expected values. The way I worked out the expected values is basically I've imagined my 20 card deck as a 20-sided die. I know some of the sides match, so basically that will increase the frequency of it actually appearing. So using that, we know if we have only 1 card, we should see it 20 times. If we have 3 copies of the card, we should see it 3 times as much, so that's 60. If we have 2, we should see it 40 times, twice as much. So now we just put all of those numbers into the equation, work out a value for every card, then we sum up all of those values and we get our chi-square value. Now we can actually do the final step of the verification. So for this, I'm just going to be using an online chi calculator to work out our probabilities. So there is one more thing we need, that's the degree of freedom. And the way to work it out is basically all of your possible outcomes minus 1. So in this one, we can see there's 10 different cards. We subtract 1 from that equals 9, so our degree of freedom is 9. Our chi-square value was, let's just have a look. So for the Coco Miro deck, it was 2.4. We'll put that in our calculator and calculate our probability. So now we can see if we reject that the Duel Links RNG system is fair, there's a 98% chance we are going to be wrong about it. But let's do it for the Shirinu deck as well. So in this one, we've actually got 11 cards, so that's a degree of freedom of 10. And the value for this one was 7.6. So for this one, it's only 67%, but still that's a 2 in 3 chance that we'll be wrong if we say that the RNG system is unfair in Duel Links. So yeah, unfortunately, chi-square is not really used to prove something, it's used to disprove something with a degree of confidence. In this case, we have failed to basically reject that the RNG system in Duel Links is incorrect. So I'm just gonna say that it is working the way it's supposed to. Hopefully you've been able to follow this, maybe even learn something, maybe you spot a mistake that I've made. So let me know in the comment section below. And if you did make it this far, all I can say is thank you for watching.